All right, today we're doing something a little different. We're not going to talk about hype. We're not going to talk about price. Instead, we're giving a cryptocurrency called Qubitcoin a full technical checkup based on a pretty deep structural analysis from back in December 2025. This is all about the engineering, the code, and the core design. And, it all really boils down to this one simple but massive question. Beyond just securing a ledger, could all that immense energy that gets spent on crypto mining actually produce something valuable for the real world? That right there, that's the entire idea behind Qubitcoin. Okay, so here's the game plan for how we're going to break this all down. First up, we'll get into the big idea that sparked this whole thing. Then we'll dig into the project's foundation. What are its core strengths? From there, we'll get real about the internal hurdles it's facing, before we look at the potential payoff if they can pull it off. We'll also cover the dangers from the outside world, and then finally, we'll land on the final verdict from this technical review. So let's dive right into section 1, the big idea. The concept is so simple, but wow, it's profound. What if the massive computational effort of crypto mining wasn't just about solving abstract puzzles, but was instead aimed at cracking real, complex, scientific problems? This is where you can really see the night and day difference. On one hand, you've got your traditional proof of work, like Bitcoin. Miners are basically just solving random puzzles, and all that energy is purely for network security. Qubitcoin completely flips that script. Its work is actually solving legitimate quantum simulation problems. That means the energy produces real, objectively useful scientific data. And here's the kicker. It's all designed to run on a standard laptop CPU, not some giant specialized GPU farm. So, with that big idea in mind, let's move to section 2 and see what they've built on top of it, the foundation. What are the core strengths that this project already has locked in? And here it is. This is probably the single biggest takeaway from the entire analysis. The project's most significant architectural risk, this idea that it might become dependent on specialized hardware, well, that's been solved. This is a total game changer for the long-term health of the network. So the crucial point is this move to CPU-only verification. Think about it. It means anyone with a regular old laptop can run a full node. That is a massive win for true decentralization because it keeps the network from being controlled by just a few players. On top of that, the science is the real deal. It's been validated by actual experts in the field. This isn't just some marketing gimmick. The project's also got a fair Bitcoin-style monetary policy with no special deals for insiders or VCs. And the early data shows the network is stable and running smoothly. Best of all, it's built to be future-proof, so they can add new kinds of scientific work down the line. But okay, let's be real. No project is perfect, right? So now we have to turn the coin over and look at the tough stuff. Section 3, the internal hurdles. What are the cracks in the code and, in the organization itself? How many core developers do you think are actually building this incredibly complex, totally new kind of system? According to the analysis, it's a team of just 5 to 7 people. That's it? And this brings us to a concept from engineering known as the bus factor. It's a pretty stark way of asking, how many key people could you lose before the whole project just grinds to a complete halt? With a team this small, that number is dangerously low, and it makes actually executing on their vision a major internal risk. Beyond just the small team, there are a few other weaknesses to keep in mind. While that CPU verification works, which is great, its performance is still pretty slow. That could discourage people from running nodes. On top of that, the tools for developers and scientists to actually use the network are still pretty basic. And finally, kind of ironically for a project all about quantum, it's still using standard cryptography that's going to need a huge upgrade to become quantum resistant in the future. Okay, so we've seen the good and the bad on the inside. But what if they can actually overcome these hurdles? What's the potential payoff here? Let's look at section 4, a world of opportunity. This is what makes the economic model here so incredibly cool. So you've got miners producing valuable scientific data. This means researchers, universities, even big labs can submit their quantum computing jobs directly to the network and pay for them. So for maybe the first time, you have real external demand for the coin to pay for a service, not just people speculating on the price. The work itself is the product. And this unique position lets Qubitcoin make a really powerful case for itself, which the analysis sums up perfectly. It offers useful proof of work like Render, but verifiable like Bitcoin without centralized GPU incentives. Now that is a very strong and very unique story to tell in the crypto world. So where could growth come from? Well, A few places. The credibility of their scientific advisors could open up huge doors in academia. The flexible design means it could grow beyond just quantum simulation and become a true decentralized supercomputer for all kinds of science. And hey, because it's still relatively under the radar, its unique story gives it massive potential to just capture people's attention. But, no project exists in a vacuum. Even with a perfect plan on the inside, there are always outside forces that can pose a risk. And that brings us to Section 5, the external dangers on the horizon. The analysis flags 4 major threats. First up, execution risk. A single bug in code this complex could be an existential threat. Second, performance risk. If that CPU verification stays too slow, the number of nodes could drop, and you risk the network becoming centralized. Third, you've got the giants, Google, IBM, who are all building their own quantum services and will fight for that narrative. And finally, there's a risk of regulation, because quantum simulation is right next door to some very sensitive export-controlled technology. So, after weighing all of that, the strengths, the weaknesses, the opportunities, and the threats, where does that leave us? Let's get to the final section, the bottom line. The experts' final technical assessment is just incredibly clear and to the point. The bottleneck is execution, not design. The core idea is sound. The architecture is solid. The whole challenge, the entire risk, lies in their ability to actually build and deliver on this brilliant blueprint. And this leaves us with the ultimate question, the one that sums up this whole project's dilemma. Qubitcoin has this absolutely fascinating blueprint for a truly useful cryptocurrency, one that could literally turn wasted energy into scientific discovery. But can a tiny team of just a handful of developers actually build that future? That remains the biggest question of all.